take down a problem based on electromagnetic induction. Now I'll dictate the problem. Two identical loops, one of copper and the other of aluminium. One of copper and the other of aluminium are rotated with same angular speed in the same magnetic field. Compare the induced EMF the induced current in the two coils. Question number B, the induced current in the two coils. Justify your answer. Let's read it once again. Two identical loops, one of copper and the other of aluminium, are rotated with same angular speed in the same magnetic field. Compare the induced EMF, the induced current in the two coils. Justify your answer. Now, according to electromagnetic induction principle, the EMF gets induced whenever the flux linking the coil or the loop changes. And we know E is proportional to d phi by dt, or E is equal to N into d phi by dt. That is mathematically how we can calculate the induced EMF. Now here, let's see, it's two identical loops and are rotated with same speed and in the same magnetic field. So when we consider these points, it's very clear that the induced EMF in both the loops will be equal, because the area of the loop is same, given that they are two identical loops. So the areas of the loop will be same and the speed or the time periods are also same, and then they are rotated in the same magnetic field. So the flux linking, the change in flux linking both the coils will be same, and hence the EMF induced in both the coils will be same. We can write the answer as the induced EMF in both the coils are same, or you can write given are two identical loops. The loops are rotated with same angular speed and in the same magnetic field, and in the same magnetic field. Hence or you can write the induced EMF in both the loops will be same. Why? Because they are identical loops rotated with same angular speed and same magnetic field, and hence the change in flux linking both the coils will be same, and hence the induced EMF will be same. Now question number B. How to find out the induced current? The current is proportional to 1 by R. Current is proportional to 1 by R, or current is inversely proportional to resistance. If R is less, I is more. Now the given coils are, one is copper Another one is aluminium. Now when we compare these two, which one has larger resistance or which one has lesser resistance? We know copper is a good conductor, so the resistance of copper will be less. For copper the resistance is less, R is less. Whereas for aluminium, comparing to copper, aluminium will have a greater value of R, or resistance is more. Therefore, the current induced in copper loop will be more. The current induced in copper coil or copper loop will be more, because the resistance of copper is less compared to aluminium. Compared to aluminium, the resistance of the copper is less, and hence the current induced in the copper loop will be more. Now take down another one. Take down the second problem. A coil Q is connected. A coil Q is connected to low voltage bulb B, and placed near another coil P, and placed near another coil P as shown in the figure. Give reasons to explain the following observations. Give reasons to explain the following observations. I'll give you the figure later. Now question number A, the bulb B lights. Question number B, bulb gets dimmer if the coil Q is moved towards left. Bulb gets dimmer if the coil Q is moved towards left. Now first take down the figure also. Let me read once again. A coil Q is connected to a low voltage bulb B and placed near another coil P as shown in the figure. Give reasons to explain the following observations. The bulb B lights. Bulb gets dimmer if the coil Q is moved towards left. Now first take down the figure. We have coil Q and is connected to a bulb. And then we have coil P connected to an AC source. The first question is why the bulb lights. For the bulb to light, we need a current. A current is flowing through the second coil Q or this closed circuit. Now from where did this current came? The current can be due to mutual induction. Why? Because we have a coil P here which is connected to an AC source, alternating current. There is an alternating current flowing through coil P which produces alternating flux. What is alternating flux? The flux which is changing with time. Alternating flux. And the flux produced in coil P also links coil Q. And this varying flux produces an induced EMF in coil Q, and hence there is a current flowing through coil Q and the bulb lights up. So due to varying current in P, the flux linking coil P changes, and hence the flux which is linking coil Q also changes, and there gets an EMF induced in coil E, and therefore the bulb B lights up. We can write answer for question A as the current responsible for the lighting of the bulb is due to induced EMF. So we can write due to varying current in P, due to varying or alternating current. You can write either varying current or alternating current. Due to varying current in coil P, the flux linking coil P changes. Or due to varying current in coil P, the flux linking coil also varies. Due to this, flux linking coil Q also varies. Or there is an alternating flux which is linking coil Q, and hence an EMF gets induced in coil B. Hence an EMF gets induced in coil Q, and bulb B lights. Bulb B lights. Due to induced EMF, there is an induced current and the bulb B lights. Now what is the second question? Bulb gets dimmer if the coil Q is moved towards left. That means you can say that when you move the coil towards left, means like this. When you move coil Q away from coil P, the bulb gets dimmer. Why? Because the flux linking coil Q reduces, and hence the induced EMF also reduces, which in turn reduces the induced current. When Q is moved towards the left, when Q is moved towards left, that means away from, I'll write in bracket, away from coil P. When Q is moved towards left, that is away from coil P, flux linking coil Q reduces. This leads into reduction in the induced EMF. Therefore, the induced EMF reduces, and hence the induced current. Flux linking coil Q reduces. Therefore, the induced EMF and hence the induced current in coil Q decreases. hence the bulb becomes dimmer. Hence bulb B gets dimmer. When Q is moved towards left, the flux linking Q reduces there, and hence the induced EMF and hence the induced current reduces, and we will have in turn the intensity of the bulb reducing, or the bulb B gets dimmer. Hope you understood these two problems.